Daniel Souza and welcome to Aptitude Academy. This is part 5 on the GRE Quant Fundamental playlist. Today we're going to be discussing real numbers and decimal numbers. Let's get started. Now decimal numbers, as the name suggests, is a way of representing numbers in the powers of 10. This is nothing new. We've been using decimal numbers ever since we were kids. Now just to get it off our list, let's represent 2816.349 in decimal numbers. Alright, now when you write a number in the decimal number system, what you're basically doing is you're placing it into certain specific slots, and each of those slots have a specific value. And each of those values have a number that's associated with them, which represents itself in powers of 10. Now, if that sounds too complex for you, let's just simplify it right now. So what you're going to do is you're going to write the number and you have a decimal point. And this is where everything starts. Now, on the left-hand side of the decimal point, you have got place values that are increasing in times of 10. And on the right-hand side of the decimal point, what you have are place values that are decreasing by times of 10. Now, what happens is 6 will be called as the units place, or it's also known as the ones place. Now, after this, the next place value will be multiplied by 10. So it will be the tens place. Then 10 into 10 is 100. So the next place will be known as the hundreds place. And this one will be known as the thousands place. Now, on the right-hand side, what you have is after the decimal point, this is the tens place. Tens is 1 by 10. Tens is 10. Now, after the tens place, you have the hundreds place. The THS means that it is 1 over 100. Then you have the thousands place. So this is how you place a number in the decimal number system. Now, when you spread these out and you multiply them by the respective place values, this is what you get. So you get 2 into 1000, 8 into 100, 1 into 10, 6 into 1 because it's a units place. Then you have 3 into tens, 1 by 10. So 4 into 1 by 100 and 9 into 1 by 1000. Now let's make this a little bit more neater. There, that's better. Now we've got 2 into 10 raised to 3 plus 8 into 10 squared, that's 100, plus 1 into 10 raised to 1, that's 10, plus 6 into 10 raised to 0, anything raised to 0 is 1, so 6 into 1, right, the units place, plus 3 into 10 raised to minus 1. 10 raised to minus 1 is 1 by 10 raised to 1 or 1 by 10. Similarly, plus 4 into 10 raised to minus 2 plus 9 into 10 raised to minus 3. Now this is how you will split it in the decimal number system. Now why this is important and why I did the entire thing is because sometimes in the GRE they're going to ask you what is the digit in the tens place or the hundreds place or the hundreds place. So you need to know your place values right? So on the left hand side of the decimal point you have the units, tens, hundreds, thousands. On the right hand side, tens, hundreds, thousands. The reason why the decimal number system was so popular was that it was easy to convert from decimals to fractions. So if you wanted 97.16 to be converted into a fraction, it would be 97 plus 1 by 10 plus 6 by 100. And then you find an LCM and then you substitute and you just complete this whole thing. Now, I don't usually do this and I advise you not to do this because on the GRE you're not going to have a lot of time. So what I suggest you is just do this thing. What I do, I take 97.16, I write it down. After the decimal point, how many digits are there? You count them. So after the decimal point, you have 1 and 6, we have 2 digits. So 1 followed by the number of digits, 0, 0. 2 digits, 2 zeros. And then you simplify this. And this is the same thing what you're going to get here, by the way. Right? If you just solve this, right, it will become 9700 if you take an LCM of 100. Plus this is going to be 10 plus 6. So it's going to be 9716 divided by 100. It's basically the same thing what you're going to get. But this is a much easier way. So if I asked you what is 2.32, how do you do it in the fraction? 232 by 100. Or 5.416, you convert it into a fraction. 5416 divided by 1, 3 numbers, 3 zeros. That's the easiest way to convert a decimal into a fraction. So converting decimals into fractions were easy. But what if you go the other way around? Try to convert fractions back into decimals. What can happen? When you convert a fraction back into decimal, there are 2 scenarios that can occur. The first scenario is, you can say 37 by 5. So if you have to convert this fraction back into a decimal, you will get 5 1s are, 5 7s are 35, 2, 0, 4, right? So it becomes 7.4. Now this is a nice decimal, right? But it ends at 4, 7.4, that's it. Now these kind of decimals are known as terminating decimals. Right? Now, there's another scenario that can occur. Suppose you have a fraction like 10 over 3. Right? Now the answer for this is 3.3333. It keeps going on. Right? We have an infinite number of 3's here in this decimal. Now these are called as repeating decimals. Now, terminating decimals and repeating decimals are both clubbed into one set, and they are known as rational numbers. But what if there was a decimal number that's infinitely long and has no repeating pattern? What do you do then? Take for example pi. Pi is the ratio 22/7. Now, pi is one of those components in math without which math wouldn't be complete. Now, when you expand this 22/7, you get 3.141592653358977932384626433833279, and it goes on to infinity. Right? Now, it doesn't fit both of those categories that we listed previously. Right? It's not terminating anywhere. Right? It goes on till infinity, and it doesn't have a pattern. Right? It's not a fixed number that's being repeated every time. It's completely unique. So, what do you call these numbers? This is known as an irrational number, and pi is a perfect example for it. So, we spoke about rational numbers and irrational numbers. Together, they're known as real numbers. Now, on the real number line, therefore, you will have all your integers, all your decimals, and all your fractions. So you'll have numbers like 0, 1, 2, 3 going on to plus infinity, -1, -2, -3 going on to negative infinity. They are all your integers. You've got decimal points like decimal numbers, as -0.2, 2.5, like that way. And you've also got your fractions, 5/2, 3/4, -1/2, and so on and so forth. Something very obvious on the real number line is this. Suppose you have -1, right? Now, everything on the left-hand side of this number is lesser than this number, and everything on the right-hand side of this number is greater than this number, right? Similarly, for 1, everything on this side, 3/4, -0.2, -1/2, -√5, everything is lesser than 1, and everything on the right-hand side, like √2, 5/2, etc., is greater than 1. Now, this seems like common knowledge, but it comes in handy when you're working with problems that require you to create intervals. Anything can be an interval. For example, now I've taken a small segment on the real number line, right? The number 4 and 5. Now, in between this can also be called as an interval. Now, here you have somewhere in the middle, you have 4.5, right? Here you've got 4.9. Now, here, although, you've got maybe 4.99, right? Now, all of these numbers fall in this interval, right? Here you will be getting something like 4.001 or something like that. So, all of these numbers fall in the interval 4 and 5. Now, there are basically 4 types of intervals that you need to know. These questions will come on the GRE, and if you make a single mistake, you will lose the whole question. Let's see what they are. 4 and 5 as our boundaries, we can have 4 types of intervals. Now, the first one says x is greater than 4 but less than 5, right? So, how you read this is, first you cover this. X is greater than 4 but it is less than 5. So, what you're going to do is, when you write the first number and the last number, you've got to be extra careful. So, your first number is x, right? X says that it is greater than 4, so it cannot be 4. So, it can be 4.1. or it can be 4.001. Whatever it is, it will never be equal to 4. And in the middle, you can have whatever you want, 4.5, 4.6, anything. But your last number, when you're writing, you need to check, right? So now this is less than 5. So it will never be equal to 5. It can be 4.999, etc. But it can never be 5. For your second interval, x is greater than or equal to 4, but less than 5. Now, since there's an equal to sign here, greater than or equal to, your first number will be 4. Anything else is just in the middle, 4.2, 4.4, 5, whatever you want. And your last element is still going to be less than 5. So it can be 4.9 or 4.999. It depends upon your range. For your third interval, it says that x is greater than 4 and less than equal to 5. So your first element is going to be greater than 4, right? So 4.1, say. Everything else in the middle, 4.3, 4.6, 4.9. And the last one can be equal to 5, right? It's less than or equal to 5. So you can have 4.99, but the last element can be 5. Now for your fourth interval, this is known as an inclusive interval. Inclusive because it includes both the boundaries. This is known as an exclusive because it excludes both your boundaries. There's neither 4 nor 5, right? So this one is an inclusive interval and it has 4 and 5. So your 4, anything in the middle, right? 4.5, 4.6, 4.7. The last one is going to be 5. You can also have single boundary intervals. Take for example, x greater than 3. This basically means that your interval should contain all the numbers from the real number line that are greater than 3. So you will start with 3.0001 because this number is greater than 3. After that, whatever you write, 4, 54, 86, 1500, goes on till plus infinity. Infinite list, right? But everything should be greater than 3. So you start with 3.0001. It has to be greater than 3, that's all. Your second interval says x greater than or equal to 3. Since it says it's equal to 3, you can start it with 3, then 3.0001, 856, 20,584, goes on to plus infinity, right? It's infinite, it just goes on. But it can be equal to 3. So it starts with 3 and then goes on the RHS. Now, this one says x less than 3. So basically on 3, everything on the left hand side will be a part of this. So since it says x less than 3, the greatest number that can be in this interval will be 2.999. So you write that first, 2.9999. That's going to be the greatest number in this list, in this interval. Everything else is going to be on the LHS of 3. So this will be 1 and 0, minus 1, minus 500, whatever. It goes on till negative infinity. Similarly, the fourth interval now says x less than or equal to 3. Since it says it's equal to 3 and it's lesser than that, so your maximum number here will be 3. And everything else will be there on the negative part of infinity. So minus infinity. Something else that needs to be discussed when discussing real numbers is known as the absolute value. Now, take for example the real number line. You have 0 in the center and you've got plus 5 here on the RHS and you have minus 5 on the LHS. Now, plus 5 and minus 5 are completely different, right? This is a positive quantity and this is a negative quantity. But your absolute value for both these numbers is exactly the same. Because your absolute value basically says the distance between that number and the 0, right? So, this will be exactly 5 units. Right? If you have 1, 2, 3, 4, like this is exactly 5 units on the right hand side. But this too is 5 units. The only difference is that it is on the left hand side. So the absolute value is 5 units for this and the absolute value for this is also 5 units. Now, mathematically, right, the absolute value for a positive number x is x and for a negative number x is minus x. Oh God, what happened to my x, right? Now, but the easiest way to know is that if they ask you for any number, just remove the sign and that is your absolute value. So if they ask you the absolute value of minus 4, it's going to be plus 4. The absolute value of minus 68 is going to be 68. Absolute value of 72 is going to be 72. So basically your absolute value is the same number, but just ignore the sign. Now before we end this lecture, let's go through some simple properties. So you have a plus b is equal to b plus a plus b plus c is equal to a plus b plus c, AB into C is equal to A into BC, A into B plus C is equal to AB plus AC, A plus 0 is equal to A into 0 is equal to 0, and A into 1 is equal to A. Now, if AB is equal to 0, then either A is equal to 0 or B is equal to 0, or both of them are 0, right? A and B are equal to 0, right? That one of these three has to be true. Now, if minus 2B is equal to 0, then it has to be that B is equal to 0. Because you already multiplying it into a negative number. So the only way the product can be 0 is if B is equal to 0. Now if both A and B are positive, then the product will be positive and the sum will also be positive. If both are negative, A and B are negative, then the product will be positive because minus into minus is plus and the sum will be negative, right? Minus and minus will be negative. Now if A is positive and B is negative, or if B is positive and A is negative, whatever it is, if they're both different signs, then AB will always be negative because one of them will be a negative sign and positive into negative is negative. But A plus B we don't know. It depends upon the quantities and which one is greater. Now the final property that you need to learn, and it's a very important property, if A is greater than 1, then the square, A square, is always greater than A. For example, let's take a number greater than 1, say 4. A is 4. A square is 4 into 4, 16. So A square is greater than A. 16 is greater than 4. Correct. Now, if A lies between 0 and 1, right, then A square is less than A. It seems weird, but it's true, right? Let's take a number between 0 and 1. Let's say A is equal to 0.3, right? So A square is going to be 0.3 into 0.3. That's equal to 0.09. So now, A square is less than A because 0.09 is lesser than 0.3. So this is a very, very important property that you need to know. If A is greater than 1, then its square will always be greater than A. And if it is between 0 and 1, the square is always going to be less than A. Alright, so this is part 5 on the GRE Quant Fundamental playlist, where we looked at real numbers, decimal numbers, and properties regarding them. In part 6, I'll be looking at ratio, proportion, and percentages. So make sure you check that out as well. If you found this video helpful, make sure you give it a big thumbs up and subscribe to my channel. I'd also appreciate it if you tell your friends about it and help me repost this on Facebook. These lectures are completely free and I do them for the benefit of the students. So make sure you download them, share them, do whatever you can to tell as many people as you can. Cheers! Make sure you guys hit that subscribe button to get access to all my videos. I release new lectures every Thursday. Cheers!